Hello and welcome everyone. I'm your host Stefan Burns, geophysicist, and today we are discussing the deep abyss of the ocean. The ocean, as you know, covers about 70% of the Earth's surface, and we've mapped less than 5% of the bottom of the ocean. So we know very little about actually what's happening on our planet, the majority of our planet. And well, a new research paper came out just a few days ago. We're recording this now, July 2026. A new research paper came out that applied machine learning to global bathymetric data. And they wanted to find volcanoes that had previously been unidentified. And they found dozens and dozens of volcanoes. Something like 76 new volcanoes were identified. Submarine volcanoes, volcanoes below the ocean waves. Some of them aren't that deep, they're fairly shallow. Others are very deep, thousands of meters below the surface. This is, a mile, 2 miles, 3 miles. And, well, the majority of Earth's volcanism actually takes place underneath the oceans because, well, that's the majority of Earth's surface area. So, we really don't know too much about what's happening with the Earth volcanically in the deep abyss, though we are starting to have better coverage of these volcanoes. Some of them are more well known than others. And we're seeing pretty significant changes occur right now with these volcanoes in Earth's oceans. Of course, we had Hungatonga Hungahapai erupt in January of 2022, which was a massive volcanic eruption, a cataclysmic eruption, ejected a huge amount of water into the stratosphere. We've had other very significant volcanic eruptions occur just in the past few years that many people are completely unaware of. If you were to rank them as compared to terrestrial volcanic eruptions of the last 150 years, they'd be right there near the top of the list. Yet again, most people are completely unaware. So there are changes occurring in our deep ocean volcanically that are quite significant. And now we've just identified 75 plus new ones, and there are likely hundreds more, maybe thousands more that have yet to be identified. So that is the goal of today's video, to explore these different volcanoes, educate you as to what a submarine volcano is, the different types, talk about some geologic oddities that exist like Tamu Massif, which is a extinct volcano that exists in the Pacific Ocean that has the same surface area as Olympus Mons, by far the largest volcano in the solar system located on Mars. Turns out, well, Tamu Massif is about the same size, surface area approximate to that of the state of Arizona. And then we will also simply just maybe find some new volcanoes of our own, because the bathymetric data is available on Google Earth and many of them don't have names yet. So we know that they exist, though there are plenty that we don't know exist because we don't have good data for them. But we are going to explore all that and more and cover some of the big historic eruptions that have happened. So let me show you Google Earth first, because this is pretty wild. And then we're going to go into what a submarine volcano is, the different types, etc. But let's just quickly look at some of these that I've identified here. So here we have Google Earth, and hello and welcome everyone. If you're watching, this is a live stream. If you're watching this on replay, hello and welcome. So on this channel, we cover what's happening with the Earth geologically, geophysically, energetically. So this is earthquakes, volcanoes, geomagnetic storms, severe weather. We also look at the sun, solar activity, space weather, planetary alignments, planetary resonances, interstellar and cosmic forces. We talk about consciousness. We talk about many different things here, what's happening and what's changing on our planet. So I do these deep abyss videos every now and then because you can't say you understand what's happening with the Earth if you're not exploring into the deep abyss. Here's Tamu Massif. It just pulled me straight in. I didn't even plan on going here, but check this out. Here's Tamu Massif, just an absolute massive, massive shield volcano from many millions of years ago. Again, these are all volcanoes underneath the ocean. So submarine volcanoes. Now, some volcanoes are right below the surface. Others do have some aerial expression. For example, Hungatonga Ha'apai has just a little bit here of its caldera exposed. Here we see Hungatonga Ha'apai erupting January 14th, 2022. And this is one day before its big VEI 5.8 eruption. And we'll see actually quite a lot as this video goes on. It's 3 minutes. It's a bit long, so we'll fast forward a little bit. But you can see it evolving very quickly here. And again, this is before its big eruption. So at this stage, it's not the big eruption. Now, clearly this is a big eruption, but it got exponentially bigger the next day on the 15th of January. This overall eruptive cycle lasted quite some time, but it was on the 15th that you had the big eruption of Hungatonga. There was an atmospheric shock wave that went around the globe that was heard by people thousands and thousands of miles and kilometers away. Ejected huge amounts of water into the stratosphere. I think it basically doubled the water content of the stratosphere, an atmospheric layer that typically doesn't have any water. It generated an electromagnetic pulse that was observed across the globe. They picked that up in Hungary with their Schumann resonances station. So this was a gigantic volcanic event, and even more so than that, it was a gigantic electrical event. You can see the lightning strikes and more, right? The Earth is not just like gravity. A lot of people think of only gravity when it comes to space and the Earth and more, and also like matter. It's also a lot of electric currents, changing magnetic fields, plasma, and more. So I do want you to keep that in mind as we go through these different volcanoes, that fundamentally what we're seeing is a surge of electrical energy coming up. It's a surge of plasma coming up, which then of course generates the more normal volcanic processes that we think of, and magma and ash and more, right? But fundamentally what's causing this is convection of the mantle, which is driven by electric currents and magnetohydrodynamics within the mantle. So that we're learning still a lot about, but that's basically what's underlying all of this is the electromagnetic force. So here we see Hungatonga, Ha'apai. Some of these volcanoes, again, have some aerial components, but for the most part, what we're looking at here, they're going to be submarine volcanoes, seamounts, things of this nature. Here's one right here, Vailulu'u. I'm not sure. At the outset, I apologize for any mispronunciations, all right? Because it's from a whole bunch of different cultures and languages, so I apologize in advance of any mispronunciations. But you see this massive volcano here coming up from the deep abyss, the abyssal plain of the ocean, which is generally flat and not really all that active. And you see these things everywhere. Here we have one, Kavachi. We don't have good bathymetric data, but that had a big eruption recently. Here we have Titan Ridge. This is erupting right now, 2026. Started erupting in May, or maybe even April this year. But this is a big underwater eruption right now, probably the largest volcanic eruption of 2026. I think almost certainly it is, because it's been so ongoing, and massive pumice rafts and more. That's one of our signs that we had an underwater volcanic eruption. Often they go undetected, but then we'll see these giant pumice rafts floating around via satellite imagery. They start to wash up on different islands, etc. So, I mean, there was one, for example, that occurred near New Zealand. Havre Seamount erupted in 2012, went completely undetected until these giant pumice rafts were seen floating across the ocean. Some of these submarine volcanoes are pretty isolated, like Brothers Volcano here, way out in the Pacific. You have quite a few in unusual areas. Deception Island right here is actually a giant volcano. Now it's not a submarine volcano, but its caldera is flooded, and in fact it's the largest volcanic caldera on the world that you can navigate a boat or a ship into. So this is a huge volcano, as you can tell. Then there's, for example, Orca Seamount, very clear caldera there. It had a huge earthquake swarm not too long ago. I think maybe less than 10 years ago, around 2018, if I'm right. And that was a significant event. Maybe the moderator on the channel can look up when Orca Seamount last had its big earthquake activity and eruption. And you even have some super volcanoes. You have up here a caldera blasted out from Gakkel Ridge. This is 1.1 million years ago, we estimate, and we can measure this across. It is 110 kilometers across. Then if we look right here, it is, I believe, about 40 kilometers, 55 kilometers in width, and it's 1.2 to 1.5 kilometers deep. So the volume on this is like 3,000 cubic kilometers, which makes this comparable in size to Toba, to Yellowstone, to basically the biggest supervolcanoes on the planet. This is at the very edge of a spreading center where you normally get, well, the majority of Earth's submarine volcanism actually occurs along these spreading centers where you have new plate being produced. And we actually have one that occurred in 1999. We had a sequence of eruptions on Gakkel Ridge that produced 3 volcanoes, as you can see here: Odin, Loki, and Thor. I'm not sure exactly which one is which, but I think it's in that order. And that produced pyroclastic flows. We'll talk about that and more. Now, going back to Orca Seamount, just because we have the data now, the last big seismic event at Orca Seamount occurred in November 2020. So you see that some of these volcanoes, seamounts, islands, etc., are very, very active in the modern day. So we've been seeing increasing activity from them, which really to me seems to be a bit of a, well, maybe not a warning sign, but something to pay attention to. Because as this continues and accelerates, and this is where the majority of Earth's volcanism occurs, well, it's good to pay attention to that. So let's learn more about deep sea volcanism and the different types of submarine calderas. Now, excuse the imagery here that show them being on land, but I think you can still apply it, okay? So you have full calderas, where it's a nice, perfect caldera, circular in shape typically. You have these eroded or horseshoe calderas, where there may be parts of the caldera that have broken, like a flank has been blasted off, there's been a landslide, a lot of erosion, etc. It's more of an open structure. And then you have a crater, for example, is going to be a smaller feature, whereas a caldera is much bigger. So craters are less than 3 kilometers in width. Calderas are broad depressions caused by reservoir subsidence. They show you where the big volcanoes are. Now here's where the majority of Earth's submarine volcanism occurs. It's at geologic spreading centers where you have new oceanic plate being created. You have magma coming up from the mantle due to convection, and as a result you get these plates being generated. It's a pretty slow process, but at the fastest spreading centers can spread about 15 centimeters per year. So that's quite significant. Now we also have intraplate seamounts, typically generated by hotspots, but that's not the only way that they're generated, because there's seamounts that don't necessarily have hotspots connected to them. So they are usually basaltic in composition. Most of these submarine volcanoes usually are basaltic in composition, meaning they have less silicone and more magnesium and iron and elements like that. They are, in general, more viscous, so they travel easier. And so think more like water, not honey. And then you also get a lot of volcanoes in these volcanic arcs, these convergent zones, where you get subduction of a plate underneath another one. Now often you'll get these volcanoes on land, but you can also get these volcanic arcs underwater. So we can look at that with Google Earth right here. If you go back, we will see down here where we actually just had a magnitude 6.4 earthquake, the South Sandwich Trench Arc. You see these volcanoes coming up. These are really old satellite images. Not too many satellites orbit around the polar regions. But you also see with our low resolution bathymetric data, these seamounts here. And some of these seamounts have actually been displaying increased activity as of late. So you see that you have the South Sandwich Trench Arc and plenty of seamounts all over as well. And we already discussed these two. But we did just have a magnitude 6.4 earthquake right in this area, as you can see. Just kind of pointing it out while we're here. Depth 26 kilometers, so this could be related to this. You go down, we'll see that this occurs in a pretty broad feature right there. Let's see if we can find that on Google Earth. So let us go back to Google Earth, and it's somewhere in here, it looks like. So yeah, there's plenty different types of these submarine volcanoes. I mean, you really can just zoom around Google Earth anywhere and find some. Actually, here's some that we can look at. These are some that were identified by the machine learning right off the coast of San Francisco, which makes sense because that's where all that software is being developed. Check this out though. A huge string of big submarine volcanoes located how far away? Located about 275 kilometers away from San Francisco. So that's a good distance. If you get a big eruption there, you wonder how that impacts the western part of California there. Don't know. Now, if you go over here, we have Axial Seamount. A lot of people know about Axial Seamount. It had a big eruption in 2015. It had fissure eruptions in 2011. Very interesting. A lot of people talk about this and kind of overhype Axial Seamount, but this is a large shield volcano. Here's the caldera right there, right along a spreading center with the Juan de Fuca plate. This is the Juan de Fuca Ridge, and you have this large volcano attached to it. And of course, here's the Cascadia subduction zone where you get magnitude 9 earthquakes. And here you get a volcanic arc, just like we talked about. But this time it's Mount Rainier and it's Mount Hood and Mount Shasta going all the way down into California. So subduction creates a lot of volcanoes, but we see that they can occur in a diverse, in many diverse forms. Here's one. I don't know the name of this. I'm sure, I would think it has a name. It looks pretty well defined here. Measure that caldera width, 3,000 meters. That's 3 kilometers. So it just barely makes that a caldera. So there's significant volcanism spread out across the oceans. Let's look at some key examples. Here we have our timeline of modern submarine eruptions going from 2011 to 2026. These are basically the biggest ones that we've had during this time frame. So we see Tagoro volcano. This is 2011-2012, a 5-month-long rift zone eruption off the Canary Islands that severely disrupted marine ecosystems. We had a massive silicic caldera eruption in 2012. This is the one that was north of New Zealand. Havre Seamount created a 400 square kilometer floating pumice raft and was one of the century's most voluminous deep ocean events. It held that title, according to researchers, until 2018-2019 with the Fanny Mayor and Mayotte eruption. And this was clocked in at 5 cubic kilometers of lava being deposited onto the seafloor, creating a new 820 meter tall volcano. So you see how we had a huge eruption here, one of the biggest. And then we see this one here with 5 cubic kilometers of lava on the seafloor being one of the biggest eruptions in general of the past 100, 200 years. And then we get Hunga Tonga, Hunga Apai in 2022, which was one of the largest eruptions, again, in hundreds of years, going back to bigger than Pinatubo in 1991, going back to Krakatoa and other large events in the late 1800s and just in general in the 1800s. So we did skip over this one. Axial Seamount had its eruption in 2015. It was the first underwater volcanic eruption or submarine volcanic eruption to be observed by an in situ station of or network of seismometers and more, because we identified that this was a significant submarine volcano, so they deploy seismographs and everything. So real-time observation with that eruption, and the seafloor on that collapsed like 2+ meters as the caldera sank as it ejected all this magma. Very, very big eruption off the coast of Oregon, Washington. Moving past Hunga Tonga, we had East Epi here, 2023. Shallow caldera activity in Vanuatu blasted ash high above the ocean and created vast pumice fields. You see a trend here, pumice fields being a clear sign of big submarine volcanic eruptions. Explosive surface breaching. Hydroacoustic sensors recorded continuous underwater explosions from Ahi Seamount in 2024. The conical volcano reaches within 75 meters of the surface. So huge explosions occurring from this just a couple years ago. And then right now we have Titan Ridge, which is still steaming and fuming, though it was more active a couple weeks ago. It is still active right now as I record, July 11th, 2026. And it's produced steam plumes going up 10, 20,000 feet, getting close to the stratosphere, and huge floating pumice rafts, which are all across the ocean, the central Bismarck Sea around Papua New Guinea. And so this is kind of what this can look like right here, the ash and steam coming up, and you get this water discoloration and more. So this is a timeline, but you see that things just consistently got bigger and bigger going up to Hunga Tonga, and it's only been 4 years afterwards. So it's not like we should expect every single year there to be a new bigger eruption, but this is a bit of a worrying trend that we're seeing here as these submarine volcanic eruptions are getting bigger and bigger. And we know that it can be really big, like beyond cataclysmic, because we have Gakkel Ridge. Gakkel Ridge was one of the biggest supervolcano eruptions in history, as far as we know. This giant caldera that I showed you earlier was created approximately 1.1 million years ago. It was a VEI-8 supervolcano eruption. Gakkel caldera and the supervolcano in general exists along Gakkel Ridge. It's the only known supervolcano connected to a mid-ocean ridge, which is highly anomalous. And so it's very unique, but you already have convection coming up, and you already have the crust of the Earth thin where you have a mid-ocean ridge. So the crust is very thin. You have the mantle almost directly exposed at the surface. Some researchers actually are stating that you do have the mantle directly exposed at the surface there. Of course, it's undergoing chemical alteration by the seawater and more. But they can check the mineral composition, see that's an ultra mafic composition, indicative of deep of upper mantle sources. And in 1999, we had a giant earthquake swarm strike Gakkel Ridge, and they went to the site of that swarm afterwards, and they sampled. They found deep sea pyroclastic deposits, basically this pyroclastic glass that was created at 4,000 meters in depth, which is insane, because that is basically telling you that it was so explosive that it was able to create pyroclastic flows even with the incredible confining, overbearing pressure of 4,000 meters of seawater, which is tremendous. There were bubbles that were trapped in these pyroclastic deposits. So it's an ultramafic composition. The crust is very thin, and they found that the CO2 level in this magma was tenfold what it is normally for a mid-ocean ridge basalt. So that's 13.5%. So the thing is, when that finally comes up and is able to degas, the volatiles are able to go out, quickly expand, that's a huge explosive event. Because if you have 1.5%, which is normal, yeah, there's a little bit of ability for expansion and more, but it's 13.5%, that is much more significant. So this Gakkel Ridge is a very unusual volcano located on the Earth. And if we go to Google Map again, I want to show you one other thing here about Gakkel Ridge and Gakkel supervolcano. It's right where the North Magnetic Pole is. The North Magnetic Pole right now, if we get this set up, yeah, it's effectively right here on the Lomonosov Ridge. So it's going this way right now. And in general, the magnetic pole in the Northern Hemisphere stays, of course, well, in the Northern Hemisphere, in the Arctic Circle, right? So the fact that we get this gigantic supervolcano where the magnetic pole normally is, and this is an inward field where the particles are coming in, that's quite interesting. Now again, you see, this is older activity. The spreading rate here is the lowest in the world. So again, the fastest spreading rates, as I mentioned, are about 15 centimeters per year for mid-ocean ridges. You have that at the East Pacific Rise, the Southeast Pacific Rise. Here, inside Gakkel supervolcano, you do get a spreading rate is about 0.6 centimeters per year. It's like anywhere from 0.6 to 1 centimeter per year. So that's significant. And again, we see that the 1999 activity wasn't that far away, and shows that in general, the magma composition across this entire ridge is highly unique, anomalous, and explosive. So personally, I think the supervolcano still exists, but I don't think it erupts all that often at a big scale. But clearly 1.1 million years ago, it did. And how this would affect the Earth, like let's say we had that happen tomorrow, I don't know what that would do because it's got 4 kilometers of water above it. But it's a VEI-8 supervolcano eruption. So it's going to be like Hunga Tonga times a billion. And how that would affect the atmosphere would be incredible. Like really absolutely insane. We're probably looking at atmospheric weather, climate shifts. Well, weather effects are going to be extreme. The climate shifts that would follow afterwards would probably last not for decades, but for centuries. Like massive climate shifts afterwards. So yeah, Gakkel Ridge was, it's a key place to research if you're interested in these submarine volcanoes. Not that too many people know about it, but it really is quite important. Axial Seamount is a submarine volcano, we discussed it just a little bit, that provides a lot of information because of how well studied it is. So it's along the Juan de Fuca Ridge off the western coast of the United States, and it's a fairly new volcano. So the summit of a caldera formed 31.2 thousand years ago, and it has a high reoccurrence eruption frequency. So averages an eruption about every 15 to 25 years. We see the most recent ones right here, 1998. There are eruptive fissures, 2011, more fissure eruptions. There's a VEI-3 in scale. The overall eruption volume equivalent to about 10 Great Pyramids of Giza. And then 2015 was the big one, causing 2.45 meters of seafloor subsidence over 12 days as effectively the entire magma reservoir drained. And so it's a very significant volcano, though it's not probably going to create any sort of apocalyptic event because it is a fairly basaltic volcano. So, and it's the volatile percentage that also matters, right? Gakkel Ridge, when we just looked at, it's ultramafic, it's very basaltic, but it has such a high CO2 percentage, it's very anomalous. Here, it flows out very nicely, so you don't have that issue. Now here is the real big one, okay? Like the big one. Tamu Massif, Earth's hidden megavolcano. Formed 144.6 million years ago during the late Jurassic to early Cretaceous near a tectonic triple junction, and it is as large as Olympus Mons in terms of its surface area. So Olympus Mons, as many people know, it's the largest volcano in the solar system that we have found. It is much taller than Everest. Its slope is about 5%, but because it is so large, it takes you about 28, 29 kilometers above the surface of Mars. Tamu Massif, its slope is only about 1%, but its surface area is the same, actually a little bit more, going up 4 kilometers from the seafloor. So it's a big one, much bigger than typical seamounts. It has this anomalously low shield shape, which is much shallower than the typical 5 degrees for seamounts. It's only 0.5 to 1.5 degrees, and it's composed of these massive basaltic sheets that are 5, 10, 20 meters thick. So this is unlikely to have generated any supervolcano eruptions. More likely, what scientists think is that it formed during an extremely active phase with the Earth's plate tectonic cycle, and there was this more convection of the mantle, and as a result you just had constant basaltic flows. You just had tons of magma come up and then flow out, creating over time Tamu Massif. So here we see the vertical exaggeration depth map here, and we see just how large it is, right? This is an absolute massive mega volcano, but it is extinct. There's no signs, as far as we know and I know, there's no signs that's active. This is from 120 million years ago, so it'd be pretty remarkable for this to still be active 120 million years later. But Tamu Massif is a monster. And let's look at that one more time here on Google Earth. Let's go over. Now here's one of the big volcanoes, the Big Island, Hawaii. If we take this all as one volcano going down to the base of the ocean plate here, right, the crust, well, it's taller than Everest, wider, bigger. This thing is nothing in comparison in size to Tamu Massif. Let's measure again. Let's just do this really quick. Let's go all the way there to the edge too. 213 kilometers across for the Big Island. All right, so that's pretty big. You know, it's respectable. We'll go back to Kamehameha there. That's a submarine volcano, the newest volcano attached to the hotspot. But look at Tamu Massif. Absolutely monstrous. And let's just get the most, well, yeah, I would say right there, 450 kilometers across. I mean, this thing is beyond massive, about the size of the state of Arizona. So let's go back to Hawaii. Hawaii is one of these places where you have a hot spot coming up, generating these islands. And, well, we have many active volcanoes on the Big Island of Hawaii. You have Mauna Loa, we have Mauna Kea, you have Kilauea. You also have, and I don't remember the name, but you have a volcano here in the northern part of Hawaii that's not that active. You also have some volcanoes, for example, old volcanoes, also some newer ones that exist on the western side. I think the one in the north might be extinct, or at least it's like mostly claimed to be extinct. But the ones on Maui aren't technically extinct, so you do have plumbing coming up from that hotspot all the way to Maui. So here we have Maui, and Haleakala could erupt, and it will erupt in the future. Then you go over here, Molokai, you see some old volcanic features, of course. Oahu has plenty. On Kauai, totally extinct as far as we know. Unlikely that it's going to ever reactivate. We don't really see any activity from this for thousands and thousands and thousands of years. So this is the Garden Island now, the safest island probably to live on in Hawaii, other than like massive flash flood risk. But Hawaii is one of these places where intense energy flow from the mantle is coming up and generating this volcanism. So it is in many ways a good, it's a good place to watch for, where it's like an overall way to check the pulse of the Earth and the heartbeat. Because if you get a lot of eruptive activity at Hawaii, then it's probably a sign that overall volcanism is increasing for the planet. And well, right now in 2026, as I record this, we're going to have the 51st episode for Kilauea tomorrow. in fact, on the 12th. I'm pretty sure I'll live stream that for you all. But 51 eruptive episodes, it's been 50 thus far, by far sets the record for Kilauea and how many eruptive episodes it's had with these lava fountains. So yeah, things are really heating up. Here is the newest addition to the family here. Kamehameha Huakanaloa, and we see the pressed feature here. Let's measure. I don't know how wide across that is. So 800 meters across. So a nice crater there. And there has been eruptive activity from that, and that may eventually become, it may transition from a submarine volcano to an aerial volcano at some point. But you see how much is built up here off to the southeast of the big island, and you kind of see the progression here. Here's Mauna Kea, here's Mauna Loa, and here is Kamehameha Huakanaloa. So Kilauea there as well. Very active, the most active volcano right now, but the big eruptions can come in from Mauna Loa, like the really big ones can come in from Mauna Loa. But you see this whole network there. So looks like the plate's going to continue tracking, and we're going to continue to get new islands. Well, the islands are going to stay in the same position. It's the islands that exist that are going to continue moving to the northwest. There are more though. Here we have Walvis Ridge. Here's a whole sequence of old submarine volcanoes generated by hotspot activity. And we see where the hotspot's located right now with the Tristan da Cunha, which is this big volcano right here. Almost like a perfect stratovolcano, as you can see. Very, very beautiful, but it can be very, very deadly. And well, we see that it's just the most recent member along this whole volcanic ridge that's gone on for millions and millions of years off the west coast of Africa. You had that big eruption, 5 cubic kilometers of material, 2018-2020, Mayotte, off to the east right here. So very poor bathymetric data on Google Earth for that, but we see where that occurred. They're basically all over the place. I have a ton that aren't labeled. I mean, I just labeled some of the big ones. There's Titan Ridge, the location of it, Central Bismarck Sea, Kavachi here, that erupted recently. You see that near the Solomon Islands there. You have a whole bunch here in Tonga in the Kermadec Trench. And these are only some of them that I've mentioned, okay? There's more there than just this. But these are the ones that I've highlighted for you all. So you see that there are a ton of these submarine volcanoes, and there's also regular volcanoes spread out across the Kermadec Trench. But a lot are under the ocean. We really have no idea what's happening with them. The global seismic network that exists, it can catch earthquakes in even the most far-flung locations that have a magnitude of about 4.5 or greater. So if you have a volcanic earthquake swarm, which often are at magnitudes less than 4.5, we may never catch it unless we have in situ observatories like we do for Axial Seamount. So we don't know just exactly what's happening with all these volcanoes, especially the ones that we haven't even really identified yet. Just look at all the different seamounts that exist here in the Pacific. Huge amounts of seamounts in different tracks and more. So it's really quite insane just how little we know about the deep ocean. And Tamu Massif was just recently identified. We just recently found this. Within the past decade, 2 decades, I think it was like 2012 or 2014 that we identified this. Maybe going a little bit further back, but we didn't really know what it was until we actually really analyzed the bathymetric data, did some core samples, and more like, oh, okay, this is like a giant submarine volcano. These guys I find really interesting here off the coast of San Francisco, right? I don't know the names for them. I'm not sure they have names for them, but we can look here. Here's how they were identified. So we see here a map showing all these new volcanoes that are identified via machine learning. And you see that there's a ton that have been found off of the west coast of North America. One reason for that probably is because there are a lot of oceanic surveys that go off, like different cruises looking for, well, they just do seismic reflection, marine seismic reflection, and often when they're going out and coming back, they leave their effectively, let's call it sonar equipment on, their side scan sonar. So I'm not surprised that we identified so many here. It's probably because we have more bathymetric data there to analyze. But look at how many occurred in this, have been found in this region here, off the coast of Central America, and also for North America. Some have been found, of course, in the Pacific, but there's tons there that we already know of, all across the Pacific. You notice how many are located in the Pacific. So the Pacific plate in general, go back. Oh, not that. The Pacific plate in general, Earth's largest tectonic plate. I mean, just look how big it is. It's massive. Also seems to be the focus of the majority of Earth's volcanism. And then Hawaii there in the center really almost being that exact pulse point where you can feel what's happening in these circulation dynamics of the mantle. Because we know that the magmas coming up here are coming from the deep mantle near the core mantle boundary due to their composition. So the Pacific Ocean is very, very interesting. We know almost nothing about it. Now, if we go back, you can check out the other more in-depth graphic to see exactly where they identify some of these candidates. So they're all spread out. And that's how I found those 4 off the coast of San Francisco. Is I looked here and I noticed that it was fairly close. And I was like, oh, okay, let's check that out. But we see a whole bunch here in the Tonga and Kermadec Trench, and we see them there for the Cocos Plate, here for the Juan de Fuca Plate, here a couple new ones south of South America, north of Antarctica, and all across the Pacific with the West Pacific Seamount province, and in the Western Pacific, or what we call Southeast Asia. So there are a tremendous amount of these submarine volcanoes, and they are becoming more active, it seems. Our record of this is pretty short. Keep that in mind. But it does seem they're becoming more active, and I feel confident saying that because, well, we had Hunga Tonga in 2022, and this was a gigantic volcanic eruption. So Titan Ridge being the latest now in terms of big volcanic eruptions below the ocean surface, and I think it's likely that we get more of those. I wouldn't be surprised, honestly, if we get another Hunga Tonga, quote unquote, to occur in the near future. I will track all this. I will keep you up to date. So if you would like to stay up to date, then please subscribe to the channel. I release videos almost daily. Smash that thumbs up button to help the channel grow. Thank you all so much for joining me today in this exploration of the deep abyss. And I'll see you all very soon. Have a great day. Thanks so much.